This is a photo of the Utah Core Research Center located in Salt Lake City. Many states have facilities like these, which house boxes of core extracted from resource exploration or scientific drilling projects. These facilities are a great resource for geologists who want fresh samples of subsurface material that haven't been changed by other geologic processes like weathering. Core boxes are organized with the uppermost sample in the upper left corner and the lowest part of the core in the lower right, almost as if you were reading lines on a page. When choosing which samples to analyze, we look for areas representative of changes in lithology, interesting structures, or alteration. When we take a sample, we leave behind a note with what sample depth was taken and our contact information so the core facility knows where the sample went. The samples we take for analysis are then labeled with their depth and with an arrow pointing towards the top of the core. Next comes the process of core logging, which is to make observations about color, structures, composition, grain size, and chemical alteration just by looking at the sample. At this scale, we refer to the rocks as hand samples and mesoscale observations, which we record in detailed spreadsheets. Some of these observations, like color, aren't as simple as just looking at the rock. We match up the color of a rock to a Munsell chart in order to standardize our observations. Along with our core logging notes, we also photograph each sample so we can refer back to them at a later point. We try to include as much information as possible in a photo, which means including a ruler for scale and the direction of the top of the core. After we make as many observations as we can, and we've cataloged all the sample photos, we choose where on the sample we want to take an analysis. In Figure A, you see the original sample in its place in the core box in the upper center. In Figure B, we have marked with a black box where we want to take a microscope slide. The red dots indicate where we want to take permeability measurements, which is to measure how easily a fluid moves through a rock. The area surrounding those other marked out regions will be crushed to a powder for other analyses. Since multiple analyses are conducted for one sample, I maintain a spreadsheet that shows which sample has which analysis. To crush a sample, we place chips of the rock sample in this tungsten carbide bowl. Then we put it in this rock crushing machine, which will shake the sample around so the disc in the bowl will break the sample. We make sure the sample is clamped in nice and tight so it doesn't move while the machine is on. The rock crusher has a separate power lever that we have to turn on before we can start to crush the sample. After the samples have been crushed, we put the powder in labeled vials. We use the powder for two analyses: X-ray diffraction, which tells us mineralogy, and X-ray fluorescence, which tells us which elements are in the sample. As you can see, we have a lot of samples. To prepare a sample for X-ray diffraction, or XRD, we pack in the powder in this metal plate and place it in this machine, which will shoot X-rays at the sample at different angles for about an hour. The XRD machine spits out peaks which look like this, which we can interpret mineralogy using specific computer programs. We will talk more about X-ray fluorescence in a later video.